In 1983, President Reagan issued a directive making GPS available for civilian use as a common good. In doing so, he opened up the door to a whole new world of location-sensitive technologies, such as map making, smart bombs, and of course, navigation. Today, GPS is so common that now all cell phones are required to have it installed to make emergency calls able to be traced more efficiently. But how does GPS technology actually work? The United States Global Positioning System uses trilateration to pinpoint the exact location of a GPS receiver. This technology has transformed modern warfare and modern civilian life, and a basic understanding of the technology should help to make it seem a little less futuristic. The first component of GPS is the system of satellites that orbits the Earth. GPS is comprised of at least 24 satellites in medium Earth orbit. Now, the reason I say at least is because there's currently 30 satellites in orbit, as new ones are built to replace the older ones. However, 24 is the minimum number required for the system to work anywhere on the globe. The main component of each satellite is the atomic clock contained inside. Because GPS relies heavily on the principles of time and distance, it is important to use the most accurate clocks we have to make the most accurate measurements. Once you have the satellites in orbit, the next step is to get a GPS receiver to find your location. The GPS receiver first calculates the distance between itself and the satellite. As you probably remember from physics, one of the first formulas you learn is the distance equals rate times time. Now, in this particular case, distance would be the distance from the satellite to the receiver. The rate would be the speed of light, because the signal is an electromagnetic wave, and the time is the time it takes for the signal to reach the receiver. The way the receiver determines the time is that the satellite sends out essentially a timestamp. When the receiver receives the timestamp, it compares the time from the signal to its own internal clock. The difference in time is the time it took for the signal to reach the receiver. This, multiplied by the speed of light, gives you the distance between the satellite and the receiver. Because these satellites are all in Newtonian orbits, their particular position can be calculated at any given time. This information is all stored in an almanac inside the receiver. Once you know the distance to each satellite, and you know where the satellite is located, you can easily find your longitude, latitude, and altitude. To do this, the GPS receiver uses trilateration. Picture for a moment that you are somewhere inside the United States. You don't know where you are, but you can see a road sign that gives you 3 different cities. You also know where those cities are thanks to your handy almanac, which includes a map. Now, you don't know where you are, but you can use trilateration to figure out your position. First, you know that you're 625 miles from Boise. This means you could be anywhere on this circle. The second line on the sign tells you that you're 690 miles from Minneapolis. To satisfy both of these conditions, you can only be on 2 possible points, the intersection of the circles. You know that you're 615 miles from Tucson. Combining all 3 of these data points, there's only one possible location, Denver, Colorado. Now, in 3 dimensions, it works exactly the same, except instead of circles, we use spheres. And because there's that extra dimension, we have to use one more measurement. The 4th satellite determines your altitude. Now, as I mentioned before, 24 satellites are required as the bare minimum. This is because with 24 satellites, at any point on the Earth, you are constantly in the line of sight of at least 4 satellites. And you need all 4 to get an accurate measurement. As you can see, GPS relies on relatively simple physical principles to give you a very accurate location. GPS is probably the most important and yet underappreciated free service we have. There's no fee to use GPS. And yet its applications are virtually endless in both military and civilian sectors. Someday, crap. Alright, I'm just going to wait. Someday soon, we will hopefully be seeing more GPS applications built into our everyday products, such as the cell phones. Whether it is used to one day drive our cars for us, or just to help us find a lost pet, GPS will someday soon become integral to human life. Thank you.